Welcome, class. Today, our session title is Week 1, Session 4, Density, Graphing, and Measurement Uncertainty. We will move slowly and make the chemistry understandable. Your goal is to calculate density and interpret simple measurement graphs. Listen for these key terms: density, mass, volume, slope, uncertainty. First, keep the three chemistry levels together. Density is a property that connects mass and volume. Two samples of the same pure substance can have different sizes, but the same density. On a mass versus volume graph, density appears as the slope, because slope means change in mass divided by change in volume. When you feel stuck, ask, what did I observe? What are the particles doing? And what symbol or calculation represents it? The core model is this. Density equals mass per volume. A steep mass-volume line means a large mass is packed into each unit of volume. Always include units such as g per mil or g per centimeter squared, and compare your answer with known values or class data for reasonableness. Do not rush to an answer. Build the model first, then let the model guide the calculation or explanation. Now, let's work an example. Finding density from data. A metal cube has mass 54.0 grams and volume 20.0 cubic centimeters. Density equals 54.0 grams divided by 20.0 cubic centimeters, which is 2.70 grams per cubic centimeter. Because both measurements have three significant figures, the density is reported with three significant figures. If several groups measure the same cube, and one group reports 8.1 grams per cubic centimeter, that value should be checked as a possible measurement or unit error. Notice how the answer comes from evidence and reasoning, not from guessing. Here is a second example. If a graph shows points near a straight line through the origin, and the line rises 30 g for every 10 milliliters, the slope is 3.0 g per milliliter. The graph does not just display data, it reveals a relationship. Now answer this self-check. What is the density of a sample with mass 36 g and volume 12 milliliters? A strong answer should include 3 g per milliliter. Hint: use density equals mass per volume. Before you leave, practice actively. Task 1. Calculate density for mass 19.6 grams and volume 2.50 milliliters. Task 2. Explain why density can identify a substance, but mass alone cannot. Task 3. Describe how an outlier might appear on a mass versus volume graph. At the end of your study, write one sentence beginning, "The chemistry idea I must remember is." For more practice and exam preparation, visit www.bridgetoexam.com.